This week, in the first segment, we're going to discuss an intro to cloud security research with John Strand. Then in the enterprise news, Symantec has some layoffs. Infection Monkey is coupled with Zero Trust, which would be interesting. Shape Security eyes an IPO after a $1 billion valuation. Lacework secures some funding. Board members, customers, and more. Firemon announced the introduction of Firemon automation. And a lot more news stories. In the final segment, we're going to talk about cloud security. What products do you need to secure the cloud or your cloud instances? So stay tuned for all that and more on this episode of Enterprise Security Weekly. This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where we talk security vendors and aren't afraid to name names. It's Enterprise Security Weekly. Cloud-first development helps your business move fast, but misconfigurations and blind spots are part of the deal. App and dev teams get the flexibility, while security teams are left with the stress of managing new risk using legacy workflows. ExtraHop RevealX provides cloud-native network detection and response, backed by cloud-scale machine learning that helps you spot threats and unify processes across hybrid environments. Learn more at extrahop.com/securityweekly. That's extrahop.com/securityweekly. Networks are becoming increasingly complex and fragmented, and digital transformation and DevOps are driving an explosion in network connectivity changes. With each new network connection, cyber attackers may gain another opening to breach or traverse the network. At Tufin, they've pioneered a policy-based approach to network security management using automation and analytics. As a result, you can make network changes in minutes instead of days, reliably and securely. To learn more about Tufin, the security policy company, go to securityweekly.com/Tufin and sign up for a free evaluation. By the end of 2020, 99% of exploited vulnerabilities will be publicly disclosed and known to IT system admins. The consequences of that fact means the burglar will already be in your house because you left the front door wide open by failing to patch known vulnerabilities. How can you keep the threat actors out? Through cloud-based automation, Automox enables you to slam the door on unpatched OS and third-party vulnerabilities across your entire Windows, Mac, and Linux infrastructure. Take advantage of a free trial with Automox to not only see the vulnerability status of your infrastructure, but do something about it within minutes. Start automating the fundamentals of cyber hygiene at securityweekly.com/Automox. That's securityweekly.com/Automox. Welcome to episode 154 of Enterprise Security Weekly. It's September 18th, 2019. I'm, of course, your host, Paul Asadorian, joined remotely by Mr. John Strand. Welcome, John.
Hey. Good to finally be back after, 2-3 weeks off? Or I think it was just 2. It was DerbyCon and SANS.
Good to have you here. Yes. I miss chatting with you. We've been respectively busy, so...
Well, yeah, it was a rough couple of weeks. Last SANS, last DerbyCon.
Yeah.
Very, very hard. But we missed you at DerbyCon, dude.
I know. I missed everyone as well.
It was a good time.
Mr. Matt Alderman joins us remotely as well. Matt, welcome.
Thank you. The gang's all here this week. Look out, folks.
That's it. A couple of quick announcements. Exciting news about our webcast program. We are now partnered with ISC Squared as an official CPE provider. You get 1 CPE credit per webcast. You can register for upcoming webcasts with ExtraHop and SaltStack. And go to securityweekly.com/webcasts. If you missed any of our previous ones, of course, securityweekly.com/on-demand. Specifically, we talk about pushing applications into the cloud and security with Logarithm on one of the ones that's on demand, so go check that out. We'll also be at Hacker Halted in Atlanta, Georgia, October 10th through the 11th. I will be keynoting. Jeff will be speaking. You can get a discount code by going to securityweekly.com/hackerhalted. If you would like to do a sponsored interview with us, you may have seen many of our sponsored interview micro segments from Black Hat. We'll be doing those at Hacker Halted. You can visit securityweekly.com/booking. Alrighty. Mr. John Strand, this is kind of a teaser for your webcast you're doing next week.
Yep.
And I am delighted to see a lot of security and attack research on cloud infrastructure. I think we've really kind of had a turning point with cloud adoption, cloud services. They've made it robust enough, easy enough. People are learning. And right now, I mean, if you're developing an application, likely some of the components are going to be in the cloud. I mean, certainly with our own internal application and the applications that we're developing, we're doing the same thing. Like, we're pushing all of the pieces and components into the cloud. But what I'm realizing is there's some pretty major security gaps that I fear are kind of like those Active Directory ones, where they're just misconfigurations and other things that don't have a lot of awareness. We talked last week about the internal service that AWS uses to provide data, including keys, that was abused in the Capital One breach. And now you and your team have done some research as well.
Yep, absolutely. And just for the record, we've been working with the Amazon AWS security team for a while on this and a couple of other additional issues. And I want to start this all out by saying that without question, the Amazon AWS security team is the best team to work with. And I'm not just saying that because, we're talking about something that we work with them on. But generally, when you're working with Google, they're very non-responsive.
Yeah.
When you're working with Microsoft, it's crazy. They have some really cool people, but some of their people are a little bit less advanced and less fun to work with. But the Amazon team, they seem like they truly and really care about trying to fix these security issues. And they almost become like partners in security research. So if you find something, they're like, wait, what about this? What about this? And it's just fantastic.
That's good.
To work with their team. So
John, quickly.
Go ahead.
Yeah, I was going to say, I think one of the reasons for that is Amazon's built a lot of their own security products in their cloud as well, and they have a vested interest in understanding how attacks happen and how better to protect their own infrastructure. So I think that's another reason why they're so easy to work with.
I think that's absolutely part of it, but I also think there's the concept of continuity. Whenever you're talking to the security team at Amazon, many of the people, especially the higher ups, have been with Amazon since the very, very, very beginning, whenever they were just selling books. And those people genuinely care about Amazon, the ecosystem, and what they're doing, and they have a really deep knowledge as far as what they're doing. And that's rare because the rate that everything grows, people are poached, they move jobs all the time. It's rare to sit down and like on a con call with like 6 people that have been working with a company since the very beginning, and they were recognized as being awesome at security and put into a great position to work through security issues.
That's cool.
So, all right, so let's get started. So this whole entire webcast isn't necessarily a webcast of like, hey, look at this really, really cool vulnerability. And we go and we come up with a logo and then we trademark it and then have a marketing campaign. But rather, we want this webcast to be a case study in how security can go wrong in cloud technologies. Paul had mentioned at the beginning, if you're an organization, you're doing anything in security or you're doing something in the cloud these days, you absolutely are. So if you're doing that, then that means you're working with some inherently complex stacks of technology. And a lot of the different vendors allow you to deploy very complicated stacks very, very quickly and quote unquote easily. And they also give you the ability to shoot yourself in the foot fairly easily as well. So for big data processing, one of the solutions that you have in Amazon is called Elastic Mapreduce, which is a stack of technologies. And I'll talk about it here in a couple of seconds. And Azure has something similar. They have HD Insight, and Google has Cloud Data Proc and Google Cloud Compute. So you have some different options as far as what you can actually work with on this from different vendors. Now, what we're going to talk about is specifically what we discovered, and you guys should be able to see my screen now. What we discovered with Amazon AWS EMR and Elastic Mapreduce. And
so wait, John, back up.
Go ahead.
Explain for our audience and myself exactly what those services do for you.
Oh, yeah, absolutely. So if you're doing any like big data processing, right, you're going to be using something like Hadoop, and I've got it highlighted here. And some of the stuff I don't even know what it is, but you're going to be using Hadoop as a file system, Elastic Mapreduce file system. You're going to be standing up Hue for management on the front end, Yarn, Hadoop, Mapreduce, Flink, Apache Spark, Ganglia. It's basically a stack of technologies. And
so let me help a little bit, because having worked for EMC RSA for a number of years, I kind of know pieces of the stack, right? So you have Hadoop and the Hadoop file system, which is kind of this unstructured data store, right? Then the MapReduce process is how do you take that data and reduce it down into data sets that you want to work with from an analytics perspective, for example. Some of that data could be stored in something like a Hive or another kind of key store system. Spark is used to do kind of like real live streaming of data into the cluster. So there's a lot of these technologies that are used depending on how the data is, one, being consumed, like is it a live stream of data, or is it kind of batch data, and these different pieces that are used then to structure data so that data scientists and or other analytics engines can work with the data.
Gotcha. So it's storage, processing, and getting data in and out, basically.
Yes.
And
basically.
Large scale
Gotcha.
data. And I think that becomes really important here in a little bit. So it stands up this stack, right? So what we discovered is just by doing a basic scan of a stack, you come up with a 3-node cluster, 55 individual unique ports that are open, and 10 different types of vulnerabilities come up out of the gate. So you come up with low, medium, high, and critical. And this gets into, I think, one of the problems with the whole idea of DevOps, not the whole idea, but one of the problems you run into with DevOps is if you're spinning up and taking down instances and applications and APIs as needed, that's great as long as you're controlling the secure baselines. And this becomes really important, what Matt's going to talk about later on in this segment. If you're working in cloud security, it's not just a vulnerability or a 0-day, but it has a lot to do with configuration management. And that default configuration management and how you spin up that configuration management is really critical.
I mean, Matt. So 3-node cluster is a default anyways, because I think it has to have mirroring and then it has the extra. So 3 nodes are always common. But what's interesting to me is unsupported PHP version 5.6.40. We all know the PHP libraries have been vulnerable forever and still are vulnerable. And here is this, and I'm going to talk about this later, why software composition analysis matters. Because you have to understand what libraries and binaries are sitting in these containers or in these environments, because some of these older PHP versions are extremely vulnerable to attack.
And I think you guys would agree with me, but I believe that a lot of people mistakenly believe that if they're standing something up in Google Cloud Compute or Azure or Amazon, then they don't have to worry about vulnerability management. They don't have to worry about patch management. They don't have to worry about configuration management. Because let's be honest, the magic of this is it just works. You can stand up, your full EMR stack, and it's working in a matter of moments. And that's closest thing to black freaking magic in IT that I think a lot of us have seen. But because the administrators didn't go through the blood and sweat and tears to actually set these things up, that means that there's a reduced understanding of what is in that stack. There's a reduced understanding of what they need in that stack, what they don't need in that stack, and there's also a reduced understanding of the vulnerabilities that exist as well.
Yeah, so visibility into it, because it's so easy to just spin it up. They don't have to worry about golden image and having the security team review all this stuff beforehand. They just literally push a button and boom, there it is.
Yep, exactly. So, and I think, Paul, you being a Unix guy from way back in the day, this is something we've been bitching about since the late 90s, where, when we first were installing things like even a web server back in the day on Linux and Unix systems, it was very hard, and we knew that system inside out and backwards. And we always complained about, packages. I remember whenever you were first coming out with RPM packages on, Red Hat, and there were people that were complaining. It's like, wow, now any idiot can deploy this stuff, and it's going to create all these vulnerabilities. And there was some logic to that. But now we're just seeing that whole problem with what we're talking about with these RPMs now being 100-fold in the cloud, and these entire technology stacks being pumped up without people having visibility or understanding.
And I think one of the problems is still the same, is in that, whether you're an admin like I was administering Apache and compiling it by hand with lots of dependencies, and something was vulnerable, I'd have to go back and do regression testing, take a timeout, right? Go back, do regression to say, if I upgrade this module, what does that break? Does it break other things? And spend hours, sometimes days, getting out a new version. And I had to take a timeout from my regular job and responsibilities to do that. Development's the same way. If a library has a vulnerability or a component has a vulnerability, that's not even my vulnerability, but I have to upgrade to the next version. It could be just the security fix. It could be I have to upgrade to the next entire, full version number to get the fix in. Now I got a regression test, see what breaks, and take a timeout from implementing new features to go fix that stuff. And that, I think, is the reason why a lot of these vulnerabilities persist for so long and crop up, because someone's got to take a timeout, right? And that means they're not fixing other bugs or coding other features.
And right now, no one's taking a timeout, right?
Yeah.
You're seeing the adoption of new technologies is just breakneck speed. And standing this stuff up, like to actually have the deep skills to understand this entire list of technologies that exists, that's a significant team to understand that. Whereas now you can just click it and it goes. And I know we sound old, Paul. I know we catch that crap all the time. But it's the same problem manifest today, but now it's much more complicated.
And DevOps lets me move fast, right? But it doesn't magically, it's not a time machine. In other words, if an upgrade is going to cause a day's worth of work, it means I'm not pushing a new release for a day, right? Or a developer or a team of developers is not working on new code for an entire day. So it still does not take away that time to implement a fix.
Yeah. So let's quickly get to the problem. All right. So the issue is you can have your base stack and you can configure it. And everything can be locked down. You can have it somewhat secure. You can even go through and upgrade the PHP versions and all of that. And you're sitting really good. Well, the problem is auto-scaling. With a number of the different services that exist, one of the benefits of deploying something in the cloud is the idea that you can establish auto-scaling, which means that as your business grows, automatically Amazon and Azure and Google will automatically scale your infrastructure to match your needs. And this is huge, right? Because if you're looking at someone like Netflix, if there's, let's say that they need 100% of their total IT infrastructure at 7 o'clock at night central, right? So the issue is if you're going to pay for a stack that can handle that 100% at that peak time, why would you be paying for that entire infrastructure at 5 o'clock in the morning or 6 o'clock in the morning or around noon when most people are at work and preferably not streaming Netflix? So if you're Netflix, you want to have that ability to scale down and scale up dynamically. And by the way, this vulnerability has nothing to do with Netflix. I'm just using them as an example of why scaling would be important, because you don't want that monstrous infrastructure running all the time. You want it to drop as it's not needed. And this is where the problem arises. So if you're working with Elastic Mapreduce, one of the components of it is Hue. And as it automatically scales up and adds more Hue instances, then those Hue instances come up in their default security configuration. And the little screenshot that I have right here with Hue, it says, since this is your first time logging in, pick any username and password. Be sure to remember these as they will become your Hue super user credentials. The password must be at least 8 characters long, upper or lowercase, one name, one number, and one special character. So as it's spinning it up, it's actually creating vulnerabilities as it's automatically scaling. So the analogy I like to give to people when I'm describing this, and this is Jordan did amazing work coming up and writing this up, working with Amazon, and he's going to be running the majority of the webcast next Thursday because this is his baby. The analogy that he kind of used is it's like an accordion. As the accordion spins up, the accordion has holes in it. You wouldn't normally see the holes whenever it's compressed all the way down, but once it starts scaling, you have these default installations of Hue that are spinning up, and all you need to do is just log in with any username and password, as long as it meets the password complexity standards, and then that is the administrator credentials for that Hue interface. So once you're in that Hue interface, and I think that this is another thing that Matt's going to talk about why this is so important, is configuration is one thing, but if you're looking at configuration, how do you know if you haven't been popped or compromised already? So with Hue, one of the things you can do is you can generate a workflow. So when you're working through and exploring data, or it's a lot like batch jobs in old databases, and, running things in PL/SQL in Oracle. So you can create little batch jobs and workflows and schedule these things to fire automatically. And that's exactly what Hue is going to do. So within the Hue interface, you can generate scheduler, generate a workflow, and then you can get a command prompt, a shell, and then you can drag and drop your specific shell directly into the Hue interface. So the entire thing can be ran directly from Bash, as it were. Now, down here, we just simply ran this particular reverse shell for Bash. It's basically running a bash command prompt, a reverse shell. So within Metasploit, you can do MSF Venom. You can say the payload's going to be a command, a Unix command, and specifically it's going to be a reverse bash shell script. Set the L host and the L port to what you want it to be. L port it as raw, and then it kicks out this little bash shell, Bourne shell. And when you have this shell and you execute it, automatically will set up a reverse shell out of that interface itself. Because you can upload shell scripts into the Hue interface, you can simply upload the shell reverse bash and then have it execute, and then you have your reverse connection coming out of that Hue interface. So this highlights, I think, multiple different problems that exist, or can exist rather, with cloud-based platforms. One, how do the application stacks that you're creating as part of DevOps and auto-scaling, how do they auto-scale? Are they pulling the security configurations while they are auto-scaling? And does it remain secure as it scales up? Number one. Number two, if you have something that has workflow capability, it has the ability to upload and execute various code samples, do you as an organization have the ability to audit your workflows and to audit your shell scripts, to audit your scheduled tasks that are running, so that you can make sure that those tasks that exist are the tasks that you expect to exist, and are they in fact actually secure? And I would also go so far as to say one more thing. Are you monitoring the network traffic that's leaving your cloud instances? So if your Hue interface all of a sudden starts opening up, shell instances or shoveling shells out to Kazakhstan, that's probably weird, and you probably want to investigate that if at all possible. Now, this particular vulnerability is somewhat interesting because it scales up and goes down with the number of systems that are using these Hue interfaces. So around December 18th, there were 900 Hue interfaces. And if you go to August 20th, there were 663. And the issue is with this vulnerability is it scales up and it scales down. When you're talking about peak times like December, you're going to see a lot more of these Hue interfaces that are exposed than lower peak times for services. And this number is also going up as well. So this is, like I said, Jordan did just a tremendous amount of work on this, and he's Rev10D on Twitter. So just a tremendous amount of work researching this. So follow him on Twitter if at all possible. And like I said, we're using this webcast next week to kind of highlight the security issues that can be identified that are not just, run an exploit in Metasploit, get shell. It's not quite as simple as just exposed S3 buckets. And it's unfortunate, I think, that a lot of security researchers, they got into that mindset of just looking for open S3 buckets, and they stopped looking at other configurations that exist. Finally, as kind of a closing for this, and I'll kick it over to you two, we have been a bit concerned that every single time that we've done a pen test with a number of different cloud services, we have discovered where the interface, something like this, has a really glaring security vulnerability. Azure with Azure CLI and the ability for any user account to generate multiple additional users on those particular computer systems. Two-factor authentication systems. This is another vulnerability we're going to write up and talk about. We just did a pen test against an organization that was using a two-factor authentication solution, and you could send a password reset to anybody, not just within the organization that you're doing. So if the customer is using this two-factor solution, you can get a demo account for 30 days with your own two-factor authentication, and you can send password reset emails to other people that are not in your organization, and you can completely modify the URL. Just knocked out my headphones. You can completely modify the URL, and you can completely modify the landing page to capture that two-factor authentication. So almost every time we're looking at this, the whole concept of cloud, even for little bursts of time, we're finding these very terrifying security vulnerabilities. And I think that there needs to be a lot more people looking into them because these things are not being addressed as nearly as quickly as they could be. And I think that more organizations need to be like Amazon and be open and welcoming and treat vulnerability disclosure as a partnership to try to fix this for their customers more so than just, hey, you guys said something bad about our product or our company, and we want to shut down your entire domain. So John, that is what our webcast is. Yeah, go ahead, Paul.
So Amazon gives you the ability to be Elastic and spin up new infrastructure, does it not also offer the ability to specify the default configuration in terms of, in this case, it would be credentials, right, which are a big problem in situations like this. Can I say that, hey, when you expand the infrastructure, these are the defaults?
Yes, you can actually do that. In fact, one of the things that Amazon has done, I think it's done now, is if you have gone with the insecure defaults, when you log in, it'll actually generate a warning, very similar to S3 buckets. You can have an S3 bucket that's wide open,
right?
But Amazon will freak out and it will tell you, hey, you're about to shoot yourself in the foot.
Yeah.
And that's another thing, and I think that people need to understand. I don't necessarily blame Amazon for this, because Amazon is basically giving you this stack, and it's up to you not to expose it directly to the internet. It's up to you to make sure that there's security faults whenever they spin up. And they will absolutely give you the ability to shoot yourself in the foot. They may warn you, absolutely, and say you're about to do something bad, but they can't be a cop and set up security for absolutely all the customers.
Well, that's the same thing with anyone's operating system platform or whatever it is, right? I mean, you talked about the early days of Linux, right? They gave you the defaults. It was up to you to turn off the FTP server. And, you know, largely they've made more secure configurations by default. But, you know, when you get into stuff complex as cloud, that security by default can really slow you down until you figure out what you're doing. So it's a balancing act.
Yeah. Absolutely. And why do you think we have CIS benchmarks, right? And you're going to see expansion of CIS benchmarks into aspects of the space. But when it comes to these types of services, and we'll talk about this a little more, it's all defined through code, right? These are all configuration files that the development and the operations teams are building to spin up this new infrastructure. So how do you know that those configuration files are secure before you actually spin up the infrastructure? Because to your point, John, right? It's easy to go look for an S3 leak, okay, because everybody knows how to look for that. But there's a lot of other misconfigurations that can lead to these types of attacks, and they're buried 3, 4, 5 levels deep. And unless you understand the interdependencies of all these different services and all the different configurations, you won't know that it's there necessarily.
It's exactly what bit Capital One, right? Well, multiple things. I mean, they had an insecure web app, which enabled that. But it's exactly what you're saying, Matt. The interdependencies that I spin up an AWS instance that happens to have a unique token or a key. That key was also trusted to other Amazon services like S3, right? And how do you figure out what all those interdependencies are? And oftentimes, in this case, you have a way to remediate, right? A lot of times remediation's hard or next to impossible. The cloud provider doesn't give you the tools necessary to close down some of these interdependencies that can lead to compromise.
Right. And it's a very difficult problem.
If you could share out my screen again. I also want to specifically call out, Matt mentioned the CIS benchmarks. And you have CIS benchmarks. A lot of the technology we just talked about isn't in the benchmark itself, but there are things like MongoDB. There are things like Kubernetes. There are things like a number of different software stacks that are commonly used. And if you're looking at trying to learn, about security for any of these different applications as they exist, I would really, really push anybody that's getting started, start using the benchmarks, or at least just reading them and then standing up the instance and going through and checking where those different configuration files are. And the reason why is there's no better way to learn about the application stacks that you're working with than using the CIS benchmarks to kind of use security as that lens. Now, I would really like it if, basically CIS had more of the technology stacks that we were just talking about, but they're only one small organization and they're doing the best they can. And to be honest, they're doing a fantastic job. But if we go back to this particular set of vulnerabilities, there are no benchmarks for these.
Right. Now, Amazon might publish some best practices around some of their services and give some guidance, but not to the same level as a CIS benchmark.
It's a resounding endorsement for one of our sponsors, SaltStack, right? They've got a webcast coming up with us, and this is exactly the problem that Mayhole and the entire team at SaltStack is trying to address. They do support the CIS benchmarks. You can import those and apply those and get basically a diff of how far off you are from a standard secure configuration, and you can also customize your own for ones that don't exist. And I think that type of technology is necessary to be able to secure when you push your services of any type into the cloud. And you can learn more when they do the webcast with us and register for that. If this is a problem on your plate today, you definitely want to tune into that. And John, you're doing a webcast next week on this particular topic as well, which is awesome. I think understanding the specific vulnerabilities really helps as well. If you're involved in any type of cloud deployment, security or otherwise, understanding how a specific attack works. I mean, that's a model we've used since the beginning of time in security, right? You understand this one attack to kind of get a feel for how threats and exposures might present themselves.
Exactly. And you should never look at it as just the specific vulnerability, right? You should always say, okay, what did I learn from this vulnerability? Well, I learned that if things scale automatically, there may be security vulnerabilities.
Yes, exactly.
I learned that, hey, if there's scripts and workflows, is it possible for somebody to upload a malicious script and workflow? And is there a way to actually audit that?
Yeah.
Benchmarks and standards, salt stack. You were discussing that just a second ago. So don't look at this as a standalone vulnerability, like an insecure S3 bucket or a way to attack Elastic Mapreduce. Take the overall lesson on how you can actually look for these configuration shortfalls in your own cloud infrastructure.
Yep. Awesome. Well, that will conclude this segment. Stay tuned. Enterprise Security News coming up next.